Hey, hi everyone. This is Rushikesh Meherwade here. Can you guys hear me? Just over the chat, if you guys can put if you can hear me or not. Perfect. Awesome, guys. Thanks a lot for joining this evening for this session. So let me just present my screen and without delay, let's get started on this event. Perfect. So can you all again quickly help me understand if you can see the screen? Yes, no? Great. Awesome, guys. So now let's get started on the topic today that is AI agents. Okay. So we are going to talk about what are these AI agents, how do we build these AI agents, why they are here, why suddenly this so much of talking about AI agents everywhere. And we will also go through a demo. So first of all, like this AI agents helps us in doing a lot of automation. Okay, guys, like some quick check. Am I audible to everyone? Any issues with my audio? Perfect. I think some are saying they can hear me. Just I got one person saying can't hear me. Perfect. Got it. Thanks, guys. So now to talk about AI agents. Now, what are these AI agents? Is something first we will try to go through. Before we even go to AI agents, let me just brief about like why you should be hearing to me, why I should be talking about this thing. So my name is Rushikesh Merwade. Currently, I work as a founder of an edtech company called as a Vidvata. We are an edtech company which also provides training courses on building AI agents in a code way, in a no code way. We have different courses to help people learn this new technologies and build production grade applications with this AI agents. Before to that, 6 months before I started all this, I used to work as a vice president of data science in Motilal Oswal, that is one of a company in Mumbai in financial trading based, brokerage based operation. And we used to handle a lot of different AI, ML based use cases. I have 13 plus years of experience in the IT industry in testing, data science, AI, Gen AI, agentic AI. Have worked across all this also in the leadership roles and built multiple systems in the production. So that is about myself. Okay, so let's get ahead. So first is like, why should we care? Even before we get started with this, can you all help me understand like what is AI agents as per you? So over the chat, just one liner. What do you think are these AI agents as per you? I want to know about the audience first so that we can define the complexity accordingly. So what do you think is AI agents? A bot doing a specific task. Okay, Raghuveer, that's good. So Raghuveer has given one answer. LLM plus tools. Okay, Ajin, so that's good. LLM plus functions serve a service, does some specific task. LLM with tools, access, memory, thought, action, observation, loop, a system which can help predefined service. Okay, set of if else statements ladder. Okay, Nilesh. Agents talking each other for a task. Independent event broadcasting, an AI system that perceives its environments, makes a decision, and takes action to achieve the specific goal. Like Kaushal, that's a great one. Looks to be very good definition of the whole thing. System that can take decisions and act without human. So all great, guys. I think that's a very great set of pointers which you guys have added there. Okay. So first of all, we will add to it. Like what are these AI agents? First, few things are like you see that LLM models have become very good in terms of making decisions. Okay. Today, you go to ChatGPT and ask it that, okay, I want to do this thing. Can you help me with the steps? ChatGPT will help you with the specific detailed steps that every single step, this is what you do, should do. You go here, do this, go here, do this, put. You will get every single step from ChatGPT. But one thing that the ChatGPT was not able to do few months back was it cannot take any action outside that. It can give you the steps saying that, okay, do this, but it cannot actually do by itself. Okay. A ChatGPT in itself is an agentic application. Why and how we will talk about it. But the pure LLM models which are there in the background, okay, the pure underlying LLM models, which we also called as the probabilistic next token predictor models. Okay, so all that thing aside, the goal of this LLMs is to understand the overall universe in a much better way and help us define those things. But they cannot do beyond that. That's where AI agents comes into picture, where they will be able to take external actions, not just tell you what to do, but also they can do those things. Okay, that's where the AI agent comes as a picture. But first thing, this AI agent can not just take actions, but they can also think through it. They can think that, okay, why I should do something like this. If things fail, they can also take some extra step that, okay, certain thing is not working. This models can recognize and say that, okay, I tried this, this is not working. Let me tweak it. And after tweaking, I can try it again. That's what this reasoning capability, it's coming from the LLMs. Then they can take actions. Actions are the core components of the AI agents. Nowadays, whenever you listen about AI agents, it is everything more than LLM, where from the LLM is just a generation, and on top of the generation, you can actually take some actions in the real world at a software level, calling APIs, calling databases, accessing the internet. All of these things comes under taking some kind of action. And these actions can be allowed to this LLM called as a tools. Okay. In the whole agentic space, we have this term called as a tools, which is defining these actions. We will define the list of actions. And then LLM or agents can make a decision which action to take based on what scenario. And they can help us automate end-to-end processes. Okay, like from understanding the results, agent can handle the full-fledged workflow that they can reason through it. For example, you want to build a software product. Okay, let's say you want to build a website. Now, building a website, you may need to first create some UI components, backend components. After that, you need to run through it, install the libraries, run the code. If there are errors, correct those errors and then run it again. So all of these are like agentic components where system can make mistakes, correct them, again take next actions, keep going on till it is able to achieve some results. Okay, so that's a core high level AI agents. So let us go further. Now, if we talk about LLM versus agents, LLMs, as I told you, are just next token predictors. In ChatGPT, you see that the tokens or the words or tokens, we also call them tokens because they're not actually words. LLM tries to see them in a slightly different way. Okay, they are token because it doesn't see the word as it is. The LLM tries to break those words into more smaller granular parts. That's why we call it tokens. And these LLMs are nothing but probabilistic next token predictors. They will be predicting one by one word. That word again goes as an input to the model. Next word again goes back as an input. Next word. Like this, the ChatGPT based models are not generating the full response in one go, but rather they are generating token by token. That's why you don't see the output getting generated in one go. It is coming slowly. Okay, so that's where the LLMs are. But these LLMs are very good in the decision making. Okay, one of the powerful thing about these LLMs is they are very good in terms of decision making. Like you guys may have already heard about things like I was not able to cure a disease from the last 10 years, but ChatGPT helped me understand like quickly my disease and I was able to solve it. And nowadays we trust ChatGPT more in terms of decision making as compared to our friends or someone else. How many of you agree with this? Agree that okay, now if we trust ChatGPT, Gemini more than anyone who's more good in that. Anyone who agrees on this? Yes, no? Okay, so Prashant says no, good. Okay, I still see there are people who say I don't trust fully ChatGPT. Good, good. But do you agree that as compared to earlier, now we don't go to our friends, colleagues, internet more, but rather we always rely first to look at the ChatGPT, right? Sometimes, yes, to a good extent, as compared to earlier, we have transitioned a lot in terms of relying more on this ChatGPT. We have got good trust. You all must be having a good trust now with respect to ChatGPT that you know that okay, if I ask something, I will still get to a good extent some pretty good response that I can compare with someone who's an expert in this area. Organizational setting, absolutely. You should be very careful when you're using with the organizational data. You should not be exposing completely to it. And it may not know your organizational data very well. So it may not be able to answer to a good extent with the internal data. But one of the goal is the chat GPTs are or the LLM which are in underlying, they are very good in terms of making the decisions. Okay. And so they were good in decision making, but they were not able to take the actions. If I tell chat GPT, tell me how can I open a bank account? Okay, in ICICI or something other, I can say that, okay, help me fill a form. These are the fields and this is my data. Tell me where should I fill what. ChatGPT can help you define all those things very well with complete details of steps, actions, everything. But till now, without agents, they didn't have the power to actually do it. But now with the agents being there, the systems don't have to just define, but they can actually do those things for you. That's a core thing. Now to do that on top of LLM, we add some more layers. For example, one is the smart brain, which is nothing but the LLM. Now LLM in AI agent plays a very important role. It is like a core brain. We as the humans, okay, we are the humans, everything is being controlled by brain, right? Like even my hand movement, my speaking, my movements, everything first go to the brain and then propagates to other organs. In a similar way, in AI agents also, LLM are like a core brain. They will take all the possible decisions. And then we have these other things like memory, tools, goals, guardrails, evaluations. All these are like some additional components. But the core agent is the brain and the tools. Okay, they play a core agentic architecture. On top of it, memory helps it to remember. These LLMs, as I again said, are just a pure token generator. They can't have a memory or a history of conversations. So this memory is a layer that we add so that it can remember the past conversations and help us like with the follow-up questions. Okay, so that's the memory, but there are a lot of other components. But pure agent is your LLM plus the AI agents. So let us go next. So this LLMs actually changed everything. One is they understand the natural language very well. Okay, they understand like even human, Hindi, Marathi, English, they understand multiple language in a very good way. Then they can generate some very good high quality outputs. We trust this high quality output. You ask it to generate a PPT, it can give you PPT based content. You ask it to generate a Word document, it will give you Word document based output. You ask it to generate a JSON, it can give you a JSON based output. So it understands your question and can provide a high quality output for you and adapt to different type of domain, be it healthcare, medical, all the situations, it is able to adapt very well. And then it is a foundation for all this AI agent concepts which are there. See, till the last year, till last year, Gen AI was in pure focus. The Gen AI was purely LLM, where you just do the generation. The last year, 2024, was more in knowledge basis. Like how do you integrate external knowledge as part of your memory or LLM generative AI? Like generative AI is purely limited to its own knowledge. But now how do you give access to the external knowledge was 2024. 2025 was tagged as the era of agentic AI. Okay, where now we started saying that, okay, let's see how this LLM can actually be used to make outside decisions. So that's where the intelligence part is available. So these agents can actually plan through the things. Okay, if you ask it that, okay, I want to do a travel plan from this place to this place, help me create a process. Or I want to do a bank transfer, or I want to buy this product. It can help you plan very well with right questions, right options, and helping you to define a step by step process that you should be following. It can use tools and APIs. So APIs, databases, web browsers, your local files, all of this can become like a tool and help you make a final uh, external access to the LLM. So all those become like external access that your LLM can use to take some actions. They can do multi-step workflows. Okay, multi-step is more of they can handle some parallel processing based operations where it's not just like a single step for the future, but beforehand they can plan for the multiple steps over the future. Then self-correct the mistakes. If you guys have used GitHub Copilot, Claude Code, this kind of tools, you will know that these models can also correct from themselves. They can make a mistakes. It's not like they cannot make a mistake. They will be making a mistake. See, we as a humans are also not 100%, right? Like we are 95%. Even experts may sometimes fail. And these LLMs are built purely on the human data, right? Everything is built based on what we as the humans have generated over the past. They're built on that. So they are not 100% correct. They will be doing a mistakes. But can they correct from the mistakes the way we humans do? We humans are good because we learn from the mistakes and then adapt over the future. So these models can also do a mistake, understand that, okay, this is a mistake I made. Let me try the change and again check. So this is the thing it can do. And with agents, we can also build some autonomous systems. But just one disclaimer, AI agents are still not at a place where they can be built with a fully autonomous system. Any application with the AI agents, wherever you will see, will always have some kind of a human supervision. Okay, be it ChatGPT, be it Lovable, Bolt, Claude Code, all of these agentic tools that you see, everywhere you will be explicitly providing some feedbacks. It's not one single iteration. You will be doing a multiple iterations over those tools to finally get what you want. So they are not fully autonomous as of yet. It's still not at that pace where it can work. Maybe for simple use cases, like some simple use cases, it will work. But for complex use cases, humans are still required to take it ahead. So still there is no full-fledged autonomy which is available in the systems. Okay. So you may hear a lot over the online saying AI agents are fully autonomous, but they are not right now. Okay. There are still a lot of challenges that we need to solve with respect to making them fully autonomous. Perfect. So now these are some of the core components with respect to the AI agents. One is a brain. The tools, memory we already discussed. Then there is a planner. Internally, these things can do a planning as a tool. Okay, because when you give it a larger task, that larger task sometimes it starts with, like, let's say there are 5 steps. It starts with the step 1. But that step one is so big that after some time, it may forget like what it has to do. There were even 4 steps. So planner helps the LLM agents to keep track of the overall activity. Okay, what is happening, how much you have completed, what all is pending. So all those things in a plan are available. And then the executions. So now where are these agents actually better? See, one challenge is in like me being in this AI ML space from past 9 years, one of the things we have seen is there were many hype cycles. Okay, there are always hype cycles, and with every hype cycle, everyone just starts jumping into these technologies without actually understanding is it even valid for the given problem statement or not. Not every problem statement need to go with the complexity. If something can be solved with a easier approach, you go with that. Then you try to add a complexity if it is not being solved with the simplicity. Okay, so AI agents are not like a silver bullet for every single problem statement. They are useful in only certain situations. It's not like they can be used in every problem statement you start throwing the AI agent. That doesn't work. But many problem statements which were challenging earlier, we are able to solve them with the AI agents now. Okay, we used to do a lot of data collection from this document. We used to build manual ML models earlier before the agentic AI. We had to create our own models by hand, which used to take even to extract one type of data. We had to spend like 3, 4 months creating the data, building a model, testing the model, integrating it. It used to take a lot of time. But now extracting data from documents, building some simple predictive systems, all those things have simplified a lot with the LLMs and AI agents. Okay, so these AI agents are good for doing some kind of a research analysis, thinking on top of it that okay, whether this is a good option or not, whether I should go more deeper into this topic or not. How many of you heard about the deep research? Have you guys heard of deep research? Like there's multiple systems provide an option for deep research. So yes, no, over the chat, like how many of you heard of it? Okay, perfect, perfect. So deep research is a agentic application. Okay, and within deep research, it's a LLM plus a browser as a tool. Okay, LLM plus a browser as a tool, and with that, what happens is the browser it is using in an agentic way to start searching multiple topics. It keeps searching multiple topics, keep gathering the data, summarizing everything, and it's not one single iteration. It is going to multiple LLM iterations, browser iterations, keep gathering the data, summarizing the data, and then finally gives you the research outcome. So research is one of a very key areas as part of the agentic process. Most of the companies are using this to like this is one of a core use cases right now that many people are using. Then multi-step automations. If you have automations which are complex in nature and lot of if-else conditions you have in your systems. Okay, if there are a lot of if-else conditions, then you have to define that, okay, if this is the input, this could be output. If this is the input, this could be output. And you have very larger context to this. Okay, and if you want to simplify, AI agents can reduce all this if-else statement into just a one single prompt. Okay, with one single prompt, you can define the like reduce a lot of if-else conditions to a limited ones. So a lot of these automations, the step-based automations you can do with the AI agents. Accessing the databases. These AI agents can understand your schema. Given a problem statement, the way we humans try to solve any type of query through the databases, we take the query, understand that, okay, there is this kind of a, for example, I've said that, okay, help me analyze last 5 years of revenue in this product. Now, the LLM can understand that, okay, let me see, is there any table with the revenue? Let me see, is there any table with the product? Is there any mapping keys with them? Get the schema for both of these tables. After getting the schema, can I understand what is the schema? And then can I create a SQL query out of it? Run the query, get the data, and give you the output. So now SQL, there are many online products or many companies that have already started with this SQL agents. They call it SQL or database agents, where based on the sentences or the normal human language, the model can actually understand your database schema and bring you the results directly. It saves a lot of effort with respect to the database engineers, okay, where the business teams can directly get started with extracting the data. Okay, extract, analyze, summarize workflows. This is one of document analysis or online research again kind of a thing where you like I used to be one of a company that I used to work earlier is a Morningstar. So in Morningstar, one of the things that we used to do was fetch specific information from the annual statements. Okay, fetch specific information from the annual statements. That used to take a lot of effort because these were 100, 200 pages document and then summarizing that. So now that has become simplified where you can extract, analyze, and also summarize those findings and connect them together and come up with some more refined findings. Okay. Software development, I don't think I have to talk about that because that is the most widely used use case with respect to the AI agents, where it is able to do a pretty good work in terms of developing the softwares. And then browsing and reasoning. Now, there are also a new type of model called as a computer use models. Has anyone heard of that? Computer use models? Anyone heard of this term? No? So computer use is a type of a model that can actually control your local system through the agents. Okay, so it's not just APIs, databases, and all those things, but it can actually control your mouse. It can control your keyboard. It can have a look like what is there on the screen at an image level. It can keep capturing the snapshots, understand what is there in the image, and then keep taking the steps. So this is more next level. These models are still new, but there's a lot of refinement happening in this type of models. Okay, so these are some different type of use cases where the AI agents can play a very important role. Now, we talk about all the good things, but there are also challenges. Okay, there are also challenges with respect to the system. They are not that easy. I'll be taking questions or the pointers in some time, but please keep putting it. I'll be looking it over the 10 minutes now. Mostly 5 minutes. We'll have a look at the code. So please keep putting your question. That's completely fine. Okay, perfect. So now let us also talk about the challenges which we have with respect to the systems. So first is the hallucinations. These models, as compared to 3 years back, now these models have improved a lot. Okay, as compared to 3 years back, the models in terms of hallucinations have improved a lot. But now, still, like some 3 to 4%, this model can still hallucinate and give you unexpected outcomes. So we still have to cater to those. The systems are slightly hard to debug because the system becomes very dynamic in nature. The way we have our software products where if this happens, do this, if this happens, do this, after this, you do this, things like that, they don't work here. Here, most of the reasoning is being taken by LLM. Sometimes understanding why LLM took certain thing as a decision, debugging that and making a correction to that is slightly tricky. The tool misuse. Sometimes unimportant tools could be picked up. Users can misuse this in terms of a security. Some people can try to hack it. There are things like prompt injection, where people can inject some unwanted prompts and make your system do things which it should not do. Then some noisy decision. Sometimes it can do unwanted decisions, as I said. Cost if uncontrolled. Now, one thing is, all these LLM models are purely based on the tokens. Okay, so as we discussed at the start, tokens are the core measure of the systems. So the input output token that the systems are generating they all have a cost in terms of the API. Now, this cost with agents, as the agents keeps thinking, refining, iterating with a lot of data, your tokens are also increasing. So it can give a high cost. Many people don't go with the agents because sometimes it can via uncontrolled iterations and can have a higher cost. So understanding why that happens, how to control that all becomes a very important part. Then the safety concerns. As I told you, there are many examples where you tell the system that, okay, you should not do this. Okay, for example, let's say you are creating a customer analytics service or customer service bot, and you are giving an access to users database to your agent. A hacker can say that I am user 5, give me my data. And the system may not actually understand this very well, that this user is actually user 7, but is asking for user 5. If you don't control it, it can actually get the data for user 5 and give it to the this user 7. So those are some security implications which are there. To handle that, there are different things called as the guardrails we try to implement on the systems to make it more reliable. So these are some different aspects which we also need to take care when we want to build the systems. Okay, perfect. So let's go ahead. Now, major benefit is they are like automate the lot of repetitive tasks which are going to be there. Any natural language steps, like we can just convert it to actions. Nowadays, coding to some level has become fully natural language. I can say that, okay, help me build this system. It can do to some level. Okay, not fully, but to some level it can do it. I can say that, okay, summarize this whole website to me and give me 5 pointers, and it can actually give me. Over the future, you will also be able to see that, okay, I can tell they transfer 10,000 from my this account to this person, and the banking systems will completely come with the agentic layer where the systems can take autonomous fund transfers, make a payment on behalf of you. That is already going on, where the systems can actually take a payments based decision also on top of for you. Scalable workflows, you can build scalability, flexible, customizable, works with API, DBs, all of it. Okay, these are like different aspects. Now let me quickly take you through building a AI agent in live and see how do we build it. Okay, do you guys want to go with that? Do you want to see building the live agents in live? Awesome, perfect. So to do that, I may go a bit faster to some level, but please be with me. So first thing, let me start a new notebook. So we will start with the collab. Before we go to the collab, one more thing I need to show is we will be using Gemini model to do that. So Gemini comes up with this website called as Google AI Studio. Okay, so from this Google AI Studio, you can log into this if you have not accessed this. Then there is this thing called as a get API key. I'm already on that page. So this is a screen where you'll be able to get a key. Okay, and I already have a key, but you can create an API key if you already don't have it, because this is something that we need for us to work with the systems. Okay, so now going next, let me show you. Just give me a minute. Perfect. Okay, so now let us go back to this. So we will be using LangChain to implement the AI agents. So first thing, before we even go for agents, we have to configure libraries. So first thing, we will go with installing the libraries. One is the LangChain with Google Gen AI. LangChain, we will be doing a bit of a stock research. So we will be using a Y Finance or Yahoo Finance library. And these are like technical indicators library. People who are from the stock research based things, they will know about technical analysis. but some level of it you will be able to understand. If you are not fully into stock, still fine, but you will get a core gist of how those agents really work. Okay. So if you want to find out that how to use LangChain with Gemini, you can just go through this website. Okay. You can search for LangChain Gemini, and then you will get a very good description that, okay, what keys you need to set, what installations you need to do, the initializations, how to call the model. So those things we will be able to do from this. Now, first thing, I need to configure certain keys. Now, this key is actually coming from the Google AI Studio. Okay, this key, if you see BW8Q. So the last part is this BW8Q. This is the key which we need. Now, on top of the key, let me create the model part. Okay, we are setting an environment variable. So this is the environment variable and model will be picking from this environment variable. Now this is the Gemini model object. We are using Gemini 2.5 Flash model. Now this model, let us first define it. And to check this model, we can do llm.invoke. Okay. I can ask who is the PM of India, something like this. Okay, this is still running. Let it finish the running. Okay, done. Okay, so now what do we really mean by the AI agent? See, we are getting the current Prime Minister of India is Narendra Modi, and it is coming based on its own knowledge. These LLMs currently don't have any background knowledge. Now, when we go and create a LLM AI agent, okay, let me first start with directly the agent. We will just comment this piece right now. And also, you are a helpful agent. Now, this is the LLM object. This is a create agent object. Okay, create agent object. Now we are defining an agent without any tools right now. So first thing to show you how this LLM really works is invoke. So when we invoke this, we need to have this slightly different structure. We have to pass this messages and we need to pass a list of message. I'll ask what is the current date. Okay, I'll ask what is the current date. Let's see what this model says. So what you see, this is the answer. Okay, if you see this is the answer, what do you think? Is it right? Do you think it is right? No. Why? Because this model do not have access to the real world. Okay, format is still fine, but more than format, the challenge here is this date. This model do not know the current date. It is trained on a historic data. So it is trying to give us like May 15, some older date. Now, if you want to give it access to the real world, what we can do is we have to create tools. Okay, so let me show you how we can create tool. So I'll define a function get current date, and then we will be using Python from datetime import datetime, and this object I'll be returning return datetime dot now. Let us call this function and see if it is working. Okay, so this gives us a date object. Now I can also just convert this to a string. And this is giving us a proper date format. Now, what does a tool really mean is tool is any function. Okay, tool is any type of function that we can give access to this model. We need to add a tool decorator. We also need to put some description. Okay, this is a tool to get current date. So now this may not work directly. Now this I can assign as a tools. Okay, So I'm now giving this function as a tool to this object. Now, once I now run this and ask the same question, okay, let me run it separately in a new cell. What is the current date? Now, what really happens is the current date is November 14, 2025. Okay, so with this tool, now we are giving LLM superpower in terms of accessing the real world. Okay, we are giving it superpower in terms of accessing the real world. That's a core goal with this thing. Okay, now one more thing. So now it doesn't have to be like right now you may say that, okay, there is only one function and we are getting the response. Now let me create one more dummy function, get secret code. Okay, this is a secret code. Now I'll return Vivata. Okay, now this is only known to us. Now, if I try to add this as a tool and ask a model that give me the secret code. Okay, so let us have a check 9. Okay, I think I have not executed this. Let me run this. This is fine, and we will run it again. So now if you see, the secret code is Vidvata. Now I can use any of the two, and the power is only one of it will be used. Okay, I can ask both questions now. Like if I run this again, now model has access to both the tools. If I ask about date, it will be able to give me date. If I ask it about secret code, it can give me secret code. On the fly, the agent is able to make a decision what tool to call. Now there is no if-else condition. Before to this, what we had to do was we defined that, okay, whether a string contains this word, if it contains this word, then you try to call this function. If not, you call this function. But now the power is all going to the agent or the LLM. LLM is making a decision. If the question is this, I'll call this tool. If the question is this, I'll call to this tool. How this decision is being made is by this description. Okay, this description plays a very important role. Okay, this description plays a very important role where we say that what is the goal of this tool and it is able to achieve based on this. If you change the description here, it may not work as is. So now there's one more type of thing that we can do is that in normal programming, it will be very difficult to do is what is current date and secret code. If I ask it now two questions together, the current date is this and the secret code is this. If you see, it is able to take one question, two question, or if we add multiple tools, like we can add some 20, 30, 40 tools. The more tool you add, it will create a confusion. So it is good to create a limited set of tools. But if you create more tools, then it becomes a challenging part. So we need to optimize how many tools we are adding, how good the model is working. So all those are different optimization systems which are present there. So this is how the agent and the LLM. Now LLM is a brain, as I told you. Hand, legs, I have it. Okay. But the brain is going to take a control in what situation I'll be raising a hand, in what situation I'll be raising a leg. All that will happen through the brain. So here also LLM taking the question, making a decision what tools to call. Now there are a lot of things are happening here. I won't be able to explain now, but if you see the logs are coming and the logs helps us understand how this model is making the decision. Okay, there is a thing called as a tool call. So actually the LLM model tells us that, okay, help me execute this tool. Agent will execute the tool and give back to the LLM, and then LLM again gives us a response. So this is a loop that happens within the system, where within this loop, there is a message, a user message. From the user message, it goes to LLM with the tools. LLM knows what all tools are present. available tools, and the question, it identifies that, okay, for this question to be solved, I need these tools. LLM can't execute the tools in a remote machine. Okay, your tool as a method is not going to the LLM. Only the definition of your tools are going to the LLM. Only definition. LLM tells us that, okay, execute this function and give me the response. Agent is a coordinator. Agent will check this message of LLM saying that, okay, execute this tool and give me the response. It can then take the output and give it back to the LLM again. And then LLM will see that this was the original question. I asked for this tool and this is a response. Now this is the final answer. So these are like the stack of messages which are going on, the communication between the LLM, agent, tools, all of it, we will be able to see from this thing. Okay, so this is the core of agents. Now we will go ahead and try to add the other layer of it, which is like now we will build a stock market research agent, okay, which will be able to fetch live data from the internet, the prices data, the news data, and then try to merge all of it together and give us a final analysis research report. Okay. Before we go to that, let me quickly tell you about if you are really interested to learn about the agentic system. We have a course that is coming on AI engineering in BFSI. This is a course link which we are the new batch. We already have multiple batches which are going on. The new batch is going to start from the 29th November. Okay, so you can have a look at this website over the time. The fees is 20,000. But if anybody is interested to apply for this course, which is a live cohort-based system, you can fill the details. I'll share the details on form in some time. But this is a price. But if you are able to do advance booking in 1 or 2 days, we will be able to reduce it to 17K. So 17K is something that we'll be able to reduce it in 1 or 2 days if you want to enroll for this course. So we have all those things with respect to prompt engineering, basics of Python, fundamentals of LLMs, prompt engineering, building RAG-based systems, AI agents, building with the line graph. Line graph is one of a very well-known library. Multi-agent systems. How do you build orchestration between the multi-agent systems? How do you evaluate the systems? Evaluation is the most critical aspect with respect to the systems. So evaluation, how do we evaluate that? How do we observe that? And then building some end-to-end use cases. Not just that, we will also be going through the deployment. How do we transform the systems into deployable systems is something that is also we will be looking at end to end, and then building a voice agents, which are also one of a new systems where people don't want to prompt with hand, but they want to communicate. So how do we build this communicatable AI agents is something we will be going through, and then a capstone. For this course, we also give like credits. We give credits to some all the well-known models like OpenAI model. Even if you need access to Gemini model with more access, a proper access, we give like $20 something that we start with. But even if someone requires more for doing some projects, we provide that. All of this is part of our course. So I'll be just providing a link over the chat for you guys to explore this. Okay, so if anybody interested, they can fill the details over the website, and also we'll share the form and we will get back to you if you have any questions on that. Perfect. So now let me continue with the stock market research agent. Now, as we already saw, what does the agent look like? Okay. Next step that we need to do is to build the AI agent. One thing we will do is first is we need to fetch a tool that can help us fetch the data. Okay, the tool that can help us fetch the data. So this is like from the Yahoo Finance, given a symbol, a stock, this should be able to fetch the stock related details. So this is the Yahoo Finance history. It will bring all the prices related data. Once we have the prices, people who are familiar with the technical analysis. Okay, MACD, RSI, these are all different type of technical indicators which are there. Okay, so we will try to add the technical indicators, RSI, MACD. So this will be calling this get history from the symbol. And from that, it will calculate different type of technical indicator numbers and return. We will be using this as a tool. Okay, we will be using this as a tool, the compute indicators. This indicator will internally call the historic data from the Yahoo Finance library, compute all these numbers, which will help AI agent to understand where the stock is moving. Is it moving up? Is it moving down? Is it moving flat? What is going on with the stock is something it will be able to understand with this tool. The next tool that we will add to this will be fetching the news data. Okay, fetching the news so that model can understand what is really happening currently with the system. So this is the external service called as a news API. Okay, this is the external service. So this news API provides a paid and a free key. Free key is more for experimental, paid key for more refined access. But only thing that you can see is we are actually calling an API. Okay, this is an API, so we can replace this with any API. So this is a one more tool. So you see that there is a tool decorators which we're adding to this. Okay, so there's a key required to access this news data. So once we have this, then next is we need to. Okay, so what we're really doing in this is there is a ticker which is going to come. This ticker we will be passing it through the query. Okay, and this URL will be called with the ticker details so that it will give us all the news data. And then we just concatenate all of these news responses, articles, and return the concatenated string. So all the news fetched, merged, and then returned. So this is a second tool. Okay, so this is our list of two tools. Tools equal to compute indicators and fetch news sentiments. On top of it, now we also need to define some prompt to tell the agent what it is supposed to do and how it is supposed to do. Okay, so we say that you are a professional stock research assistant. This is system prompt, which is like a more instruction prompt. Then your job is to gather the data from the technical indicators, then the news data, and then be factual, be consistent, don't hallucinate. These are your rules. Always you should rely on the rules. You should not go beyond the tools. Never make any assumptions. Provide final recommendations based on only this piece of information. And the output should have this kind of structure. So this is the instruction which we are providing to the model saying this is how we want the response. Okay. Then comes the agent. Okay, we are again creating the agent. Now there is a system instruction. Okay, earlier we changed the system instruction only to say that, okay, you are a helpful assistant. But now here we are giving system instructions, LLM object, and the list of tools. Okay, so we run this agent. Now we are not running it yet. Now to run it, we need to provide one more query. Okay, so perform a full stock analysis for Apple. Required step, you go for technical analysis, headlines, interpret, and produce the final results. So let us run this. It will require some time because this is going to do multiple iterations. If you see, agent has internally called these two functions. I've added this print internally. For example, this is one print and this is one print just to see that the tools are being called. So the prints are coming means agent has called those tools internally. Okay, so it has finished. Let us have a look. Now this is like a list of messages. Okay, there's a lot of list of messages. What we will do is we have to always pick the last message. Last message means -1. Okay, so this is last message. Okay, we have to go with this messages. And from this messages, we need to pick up the last message. Okay, so this is the last message. From this, we need to go to content. Again, content is an array, so we need to go with 0. From this, we only need to pick up the text. So let me filter text, and this we need to print. So if you see, based on the RSI, MACD, all those values which the tools are fetching, it is able to come up with a report. Now this report is being followed based on the system prompt which we have given. Okay, system prompt says that, okay, you go with first technical indicator, market sentiment summary, interpretations, and then the final outcome. This strategy is called as a COT strategy, chain of thought strategy, okay, which is more useful to make model do things with a more refined output. Okay, so we see all those 4 different components: interpretation, final recommendation, it says hold. And also it comes up with a reason saying that, okay, why Apple should be hold. Okay, so as you can see, we just quickly implemented 2 different functions. Without agents, you have to orchestrate between these multiple functions. Reasoning becomes a difficult part. That, okay, we are able to fetch it, but how do we summarize it? How do we try to give it in a right format? So all that is being done by LLM agents. Okay, agent is able to pull the data, combine it, provide a reasoning out of it. Right now there are 2 tools, but we will be able to add multiple tools. Right now both tools are being called, but it doesn't have to be. Sometimes we would think that, okay, only 4 tools are required to solve the problem. If I ask it, only give me news related update, it will be able to do that. Right now the system prompt actually says you should do it, but if you limit it and only ask it to give me news related update, it may be able to give you only the news tool. It will not call the other two. Okay, so in this way, we can build our AI agents which can do their own decisioning, routing to the multiple tools, and also iterations. If one go you are not able to get the data, it can do multiple go. Okay, for example, browsers, web search, it may not be only one keyword. It may try 4 keywords for you, get the data for all the 4 keywords, summarize, and then give it to you. That's the power of AI agents, where it is not just like a fixed workflow, whereas it's a very dynamic workflow to achieve the goal. Okay, so I hope this demo, I was able to give a quick picture to you all that how the systems really work. Okay, so quickly, if we, this was the agent which we built. Okay, and as a next step to the systems, what really happens is like, how do we add a memory? The system, if I ask it a follow-up question, it will not work. Okay, if I have to ask a follow-up question, it will not work. So how do we make it more focused on like follow-up also it should be able to handle? Adding multiple tools, providing it an external knowledge like vector database. You may already have financial reports and all processed in your organization. You want to leverage that also rather than every time going online. You want to leverage that internal knowledge. You can also use vector databases. Setting evaluations. Traditional like the other software systems, the output, you can always say that the result of this function, if given this input, it should always be this. Okay, in the normal software products, if you're giving one input to a function, output should be same. Even if you give that input same again, output should be same. But with LLMs, same input to the same function, output will not be same. Okay, even with the same input, same function, output will be slightly different. So how do we evaluate this kind of a systems? So that's where the evaluations comes into picture. Then deploying this as the API so that other systems can consume it and building a full-fledged automation. So there are just a lot of different pieces to this, but we have covered like the tip of the iceberg with respect to what are these agents and how do we build it. Okay, so with that, I'll stop on the session and I'll be able to take the questions if there are. So please go ahead. Like if you already put a question above and I was not able to see, please put it again. Okay, so because there are a lot of different things. So if you have any questions, please put it again and I'll be able to take it. Okay, so let me stop sharing the screen. Okay, so Guys, like please go ahead with any questions which you have. So guys, like was it useful? Did you guys like the session? Was it useful in any way? Yes, no? Awesome. Great, great. That's that's really good to hear that it was helpful to you all. Awesome, awesome. So one thing I see is what is NA10? Okay, so NA10 is basically one of a like again a no code agent builder, but it's not just agent. No code is like NA10 is more of agent plus the other different type of tools. Okay, so agent, the NA10 like allows you to build some integrated systems with the agents. Now, having LLMs, like building workflows have changed a lot. Now, what do you mean by workflow is if this happens, you should do this. If this happens, you should do this. Traditionally, we used to have a lot of rules to define this. But now LLMs can solve these things in a very different way. So NA10 gives you a workflow building like it gives you a workflow building strategy where LLM plays a very important role in routing things. Okay, like if this is a message, understand it through the LLM, and then take it to this step, summarize this thing, extract the data from here. All of those things, NA10 will allow you to do it. Okay, so awesome. And we're going to start with our new cohort where we are just going very deep in terms of how do we build the systems, what kind of challenges and all. So if you or anyone in your close colleagues are really interested in this, so please share it with them. So it will be useful to them. So and only for today and tomorrow, we will be able to provide the discount. So if you're able to register, so please fill the form that is shared over the chat if you need more details, and we will get back to you. Okay, so prerequisite for starting to create any agents, considering I'm in development role, the developers are familiar with coding. So Tejaswini, like one thing is you need to be good with one is Python. Python and JavaScript, both Python, TypeScript, JavaScript, those are core languages right now being used to build the applications. So if you want to start building agents, directly going to agent is something that is not suggested. You have to understand how those LLMs work internally. What is the fundamental? You don't have to go very deep, but at a high level, how the systems are actually working. What is a prompting? Because prompting plays a very important role. After the prompting, you go to agents and the RAG. RAG also like more in the industry LLM-based use case, the widely used LLM use case is the RAGs. So we should also understand how do we build the RAG, what are the challenges with the RAG, and then go for the agent. After you learn the agent, the guardrails and evaluations plays a very important role. So guardrails, evaluations, MCP, A2A, all of these are like, this is what a flow I would say you should follow. Okay, programming background to create agents. Kunal, like not fully programming background is required to build the AI agent. There are a lot of no-code tools. If you understand the fundamentals, even using the no-code tools, you will be able to build some good outcomes like NA10, make.com. There are just different type of no-code tools. So using, for example, Microsoft Copilot. Okay, Microsoft 365 Copilot is also one of a tool. So there's different tools you can use to build the agentic applications. Okay, so programming is not like a compulsion, but if you want to build some very fine-grained systems, then programming is something required. How can we measure the token consumed when an agent is executed? So Surya, like there is a thing called as observability. So observability is one of the components where all of the systems are tracked. What is the prompt that you're using? What are the tokens? How many tokens? What's the cost? What's the input output which is coming? So all of that gets tracked over this observability tool. We also call it tracing. So through this tracing, you will be able to understand how many tokens, what LLM models, what was the input, what was the output, all of that. So Raghuvi, you have this question as can you assign one agent as a tool of another agent? Yes, we can have one agent being assigned as a tool for the another agent so that one agent can control other agents. Okay, the way we have seen the tools are being dynamically controlled by the agent. Same way, you can also give it agents and one agent will be able to coordinate with multiple agents. Okay, so that is absolutely possible. Okay, so there are different strategies to do that multi-agent. One is a handoff strategy, other is this tool as a strategy. So there are different type of strategies to achieve the same thing. Perfect. I think great guys. Thanks a lot for being here. I hope this was a helpful session to you all and you are able to understand from the noise that is going on everywhere about just AI agents being just a silver bullet for everything. That is not the case. They are good, but they are not like everywhere. You can have some specific use cases, but they are not also foolproof. They also have challenges to implement them. So understanding the core concepts become the important part. Okay, thanks a lot, everyone. And please fill the form if you have any questions, any queries, we'll be able to answer that. So for feedbacks also, please fill the given form. Okay, thank you very much, everyone. Have a great time.